Hey listeners, are you ready to uncover some extraordinary wonders? Disappearing Spoon is thrilled to partner with the amazing Curiosity Box. It's a science subscription service for curious minds. It's created by Vsauce, the internet's leading science education channel, with over 3 billion views. This season's box is packed with goodies that will fascinate and inspire you. Challenge yourself with a magnetic shadow alphabet puzzle. Piece it together to spell out the alphabet using only the letter shadows. Or discover the picture pot, where art and mathematics merge into a colorful, creative masterpiece. It is fun and educational. And the highlight, a sample of recreated Martian soil. Experience the thrill of holding the red planet right in your hands. Don't miss out on this unique adventure. Subscribe to Curiosity Box now and celebrate the incredible achievements of science. For 50% off, use the offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon. That's offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon for 50% off today. Unbox the mysteries of the universe with Curiosity Box. Arthur Eddington could only look up at the clouds and sigh. That month, May of 1919, was a time of both elation and frustration for Eddington. He was on the island of Principe off Africa, 4,000 miles from his home in England. He'd come there to photograph a solar eclipse, a project that would serve as a crucial test of Einstein's theory of relativity, which was exciting. Eddington believed passionately in relativity, and he wanted to give the theory a boost. Still, so much had gone wrong. The humid, dripping weather on Principe had been hell on the telescopes and cameras. Then monkeys started stealing their equipment and disappearing into the jungle. Worst of all was the clouds. Every stinking day there were clouds, which obviously was not ideal for photographing the sky. On the day of the eclipse, clouds blocked the sky completely. Eddington could only gaze up and despair. Not only was this ruining his chance to confirm relativity, but if he failed, he could face serious repercussions back in England. In fact, the only reason he was not in prison then was because he had promised to photograph this eclipse. But at the height of his misery, as if moved by the hands of God, the clouds suddenly parted. Eddington didn't even have time to rejoice. He pounced on his equipment and started taking photographs. He was moving so fast, he had no idea whether they would turn out, and no idea what he would do if they did not. From the Science History Institute, this is Sam Keene and the Disappearing Spoon, a topsy-turvy, science-y history podcast, where footnotes become the real story. In 1915, Albert Einstein proposed his theory of general relativity. It aimed to overthrow the laws of Isaac Newton. Einstein's theory was wildly controversial, and no wonder. Put yourself in the mind of someone back then. Newton basically invented science as we know it. He did fundamental work on light, gravity, and motion. He also figured out how to fuse math and science together. He was the greatest scientist in history. Now this Einstein fella says he can do better? Come on. Einstein was well aware of this skepticism. So he proposed some do-or-die tests that would definitively prove or disprove his theory. One involved how gravity could bend light. Now that might sound odd, gravity bending light. But according to Einstein, E equals mc squared. That is, energy has some mass. Light is energy, so light must have mass. And if something has mass, gravity will tug on it. So imagine a ray of light from a distant star. If its path strays near our sun will tug on it and deflect it. It's like a bullet zipping past a giant magnet. The straight path bends. The test Einstein proposed involved measuring that bend. Imagine some stars in space. They emit light that streams toward Earth. So when you look up at night, you can see those stars in certain positions in the sky. Now imagine those same stars, but in a patch of sky near the sun. The stars still emit light that streams toward Earth. But this time, the sun bends the light before it reaches us. So each star now appears shifted to a slightly different spot in the sky. Normally, it's impossible to see those shifts because the sheer brightness of the sun overwhelms every other star in the sky. But during an eclipse, the sun dims. Suddenly, you can see the stars in their new shifted positions. Now, there is one nuance here. Isaac Newton's theory also predicted that gravity would bend light. Newton thought of light as a stream of tiny particles, and he once proposed, in passing, that gravity could bend those light particles. Crucially, though, Newton's theory and Einstein's theory made different predictions about the degree of bending. Einstein's theory predicted twice as much bending. So that was the test Einstein proposed. Photograph some stars in the sky at night to determine their true positions. Then photograph those same stars during an eclipse when they're right near the sun. Finally, superimpose the two images on top of each other. Then measure the deflection of starlight by the sun's gravity. If the deflection was one value, Newton was right. If the deflection was twice that value, Einstein was right. Easy peasy. Except things were not easy at all, given the state of the world at the time. Einstein was German, and most of the world despised Germany for starting World War I. It didn't matter that Einstein hated the warmongering German government and later renounced his German citizenship. To outsiders, especially in England, Einstein was a dirty Teuton, and that was that. But there was one English scientist who did not despise Einstein: Arthur Eddington. Eddington was a classic English eccentric. He lived with his sister Winifred his whole adult life and never even tried to date or marry. He believed that all matter in the universe was conscious and could think. And not just living things like animals, but cars and thumbtacks and fingernail clippings. Everything was conscious. He also dabbled in numerology. In cloakrooms, he insisted on hanging his hat on peg 137 because that number often arose in his equations. Frankly, Eddington had something of a man crush on Einstein. He worshipped Einstein as the greatest scientist of the age. He wasn't wrong, obviously. But Eddington believed in Einstein's theory largely because he found it so beautiful. Eddington felt that no theory so elegant could possibly be wrong. Eddington supported Einstein for political reasons as well. Eddington was raised a Quaker, and he was a committed pacifist. As such, he became a conscientious objector during World War I and refused to serve in the army. This was not a popular stance. Conscientious objectors in England had to wear armbands in public, a tactic to shame them. Many were thrown in prison, too. Eddington himself faced jail time. Einstein was also a pacifist, and he faced just as much ridicule at home. That was another reason Eddington admired him and felt a kinship. Furthermore, Eddington wanted to heal the world after the war, and he thought that an English scientist confirming a German scientist's theory might help both sides bury their grievances and forget the brutality of the Great War. But again, supporting a German scientist was deeply unpopular, especially when that German was trying to overthrow the ideas of one of the greatest Englishmen of all, Isaac Newton. During one debate about Einstein's theory, a member of the Royal Society Scientific Club in London pointed to a portrait of Newton hanging on the wall. He fumed, "We owe it to that great man to proceed very carefully." In other words, watch out, Einstein. Another English scientist even claimed that Einstein's theory of relativity was a threat every bit as bad as the sinking of the Lusitania, which, for context, killed 1,200 people. Talk about hyperbole. Still, some British scientists agreed with Eddington. They thought that confirming Einstein's theory might be good for post-war relations. They also made a sly calculation. If Einstein was right, he was going to be proved right by someone at some point. And that someone might as well be English. So in 1917, they hatched a plan. Again, Eddington faced harsh prison time as a conscientious objector. So a few well-placed colleagues called some political friends. They proposed that Eddington be spared jail time on the condition that he observe the upcoming eclipse in 1919 and test Einstein's theory. Photographing the eclipse was Eddington's get-out-of-jail-free card. During the May 1919 eclipse, the sun would appear high in the sky near a cluster of stars called the Hyades. On a cosmic scale, the Hyades are pretty close to Earth, just 153 light-years away, a mere 900 trillion miles. The Hyades appear in the constellation Taurus. There's a lot of stars in the cluster, and they're quite bright. This gave Eddington lots of possible stars to measure the bending of light due to gravity. The eclipse started in Peru and arced its way across the Atlantic Ocean toward Mozambique in Africa. Eddington's destination, the island of Principe, sat in the ocean 110 miles west of Africa. The island was an old Portuguese coffee and cocoa colony. For Eddington, the upside to doing the observations in Principe was its relative proximity to Europe. The downside was the frequent cloud cover, which could scotch the whole mission. So Eddington arranged for a second, backup mission to observe the eclipse in northwest Brazil. The Principe mission planned to use a 13-inch telescope. The backup Brazil mission would have another 13-incher, plus a 4-incher as a double backup. The telescopes would focus their light onto photographic plates to capture permanent images of the stars. The accommodations for the Brazil crew turned out to be pretty posh. The government there granted the astronomers access to Brazil's first automobile to help move equipment. The government also gave them an ice machine. Pretty fancy. Things in Principe were more rugged. Eddington's headquarters was an abandoned plantation on the edge of a tropical jungle. The jungle was home to a clan of rowdy monkeys, which the Englishmen found funny at first. Who doesn't love a rowdy monkey? But these monkeys were too rowdy. While Eddington and his assistants were setting up their equipment, the monkeys would dash in, grab some vital part, and sprint back to the jungle. The Brits in their stuffy suits would have to race after them. They usually recovered the equipment, but not always. The monkey shines quickly got irritating. Then the morning of the eclipse dawned cloudy and stayed cloudy. During the eclipse itself, the world dimmed right on schedule, but Eddington couldn't see a damn thing. He could only groan and hope things were going better in Brazil. Halfway through the eclipse, though, around 2 p.m., the clouds broke. In the darkness, Eddington scrambled to take pictures. Originally, he had been hoping for several dozen. In the end, he got 16. Not great, but not a disaster. At least, not at first. After Eddington sailed back to England, he developed the photographic plates. The results were not good. Of his 16 images, only 2 had enough stars to be useful. Now, the deflection of light on those images did support Einstein's theory over Newton's, but 2 images was a shaky foundation for a revolution. He would just have to wait to hear from Brazil and hope for better news. Unfortunately, he waited quite a while. Given the primitive state of travel and communications then, Eddington sat and stewed until October before he heard the results from Brazil. 5 bloody months. And what he finally heard was more bad news. As a small ocean island, Principe had quite consistent temperatures. Even during the eclipse, when the sun was blocked, the temperature dipped only a few degrees. That was not the case in Brazil. The Brazil site was situated far inland, and when the eclipse blocked the sun, the temperature dropped hard and fast. That was a problem because the 13-inch telescope there had parts made of metal that expanded in heat and contracted in cold. So when the temperature dropped, those metal parts contracted and warped. It wasn't a lot, but it was enough to ruin the focus of the telescope and the images of the stars. Instead of sharp points of light, the images were smeared. That made the pictures all but useless. Eddington moaned. Would nothing go right? Thankfully, the 4-inch telescope in Brazil, the double backup, had come through. Because that telescope was far smaller, the contraction of its metal parts had been smaller too, which meant less distortion. As a result, the images of the stars came through beautifully, nice and sharp. And when the deflections were measured, they matched Einstein's predictions to a T. Eddington finally had his proof. Last episode, we heard how Einstein investigated the anomalous orbit of Mercury. He said that something snapped inside him during that golden moment when his theory proved correct. Eddington experienced a similar elation when the eclipse results came through. A surge of emotion, a flood of endorphins. He had just overthrown Isaac Newton. Eddington called it the greatest moment of his life. And the public shared his enthusiasm. When Eddington announced the eclipse results in November 1919, newspapers in London and New York ran delirious headlines, like "Revolution in Science," "Lights all askew in the heavens," "Men of Science more or less agog." What a great word, agog. Anyway, overnight Einstein became a worldwide celebrity, the most famous scientist in the world, and it was mostly thanks to Arthur Eddington. It's easy to see why the public loved this story so much. Eclipses are inherently dramatic. Since ancient times, they've been taken as signs of big things: wars, assassinations, disasters, and revolutions. Einstein himself and his personality also made the story fun. Here was a frumpy-haired, lovable mensch with a great sense of humor. After the eclipse announcement, a reporter asked Einstein how he would have felt if the results had not supported his theory. Einstein answered, "I would have felt sorry for the dear Lord. The theory is correct." Beyond the eclipse itself, the story caught fire because the world simply needed some good news after 5 ugly years of war. Einstein gave people something to celebrate. He also provided hope for future reconciliation. As one writer put it, a new theory of the universe, the brainchild of a German Jew working in Berlin, was confirmed by an English Quaker on a small African island. Philosophers were agog as well. One later held up Einstein and the 1919 eclipse expedition as the best example he had ever seen of how science should work. Einstein had developed a new theory of nature. He then proposed specific ways to test his theory with experiments whose results would either support his theory or prove it wrong. There was nothing muddled or ambiguous here. Einstein made clear predictions, and the experiments gave clear yes or no answers. It was a big gamble, but in winning it, Einstein deserved his fame. Einstein himself, however, was mostly bemused by this fame. After all, he was a physicist, dealing with obscure things like the curvature of space-time. Why did people care? But people could not get enough. Einstein's name and likeness appeared in movies, in pop songs, on radio jingles. He landed on the cover of Time magazine. He attended movie premieres with Charlie Chaplin and marched in the Rose Bowl parade. The constant attention bewildered Einstein, but he mostly enjoyed himself. And it all started with the 1919 eclipse. Some other scientists, however, did not enjoy Einstein's fame. Within Germany especially, many people resented him, in part because he was Jewish. They called Einstein dirty slurs, and they smeared relativity itself as, ugly quote here, Jew science. Jew science was supposedly unnatural, too abstract and counterintuitive, unlike the safe quote-unquote Teutonic science of Newton. Einstein's enemies also conflated scientific relativity with moral relativism, which didn't make sense, but to them made Einstein an enemy of all things decent. They didn't just call Einstein names either. On 2 separate occasions, thugs broke into Einstein's apartment in Berlin and ransacked it. He also appeared on a list of Jews that far-right figures wanted to assassinate. Even among those who didn't want to kill Einstein, many scientists still did not buy his theory of relativity, despite Eddington's stunning results. Convincing these skeptics would require even more heroic efforts by yet another oddball scientist. This scientist would test relativity by ascending to record elevations in what amounted to a giant beer keg. And he would thereby inspire a generational hero for all science nerds.
I'm Captain Jean-Luc Picard of the Federation Starship Enterprise.
I hereby formally request third-party arbitration of our dispute.
All that and more next week. This is the Disappearing Spoon podcast, brought to you by the Science History Institute. Find out more about their library, museum, and multimedia magazine at sciencehistory.org. Make sure you check out the Science History Institute's other awesome podcast, Distillations. You can find their in-depth narrative stories and interviews about everything from space junk to sex, drugs, and migraines, anywhere you get your podcast, and on their website, distillations.org. You can find more incredible stories from my books at samkeen.com. You can also book me as a speaker at your school or event. If you like this podcast, please support it at patreon.com/disappearingspoon. It costs as little as 7 cents per day. You can also get bonus episodes and signed books. Please spread the word to others as well, and subscribe in iTunes, Stitcher, or other places. This episode was written by me, Sam Keen. It was mixed by Jonathan Pfeffer and produced by Mariel Carr and Rigoberto Hernandez. Thanks for listening.